just kind of, first of all, a heads up for what we've got between now and, well, not quite winter break for us, but getting closer to it. So on Canvas, I just updated the Unit 4 calendar just to kind of, so this is everything from Unit 4, and Unit 4 is the beginning of the trimester. So we talked about Newton's laws, Newton's third law in particular. We talked about conservation of momentum, and then we've got one more concept that we're going to do. So that concept is coming up today. It is the impulse momentum theorem. So we're going to start that today, just a little bit here, kind of touch in. I'm going to give you a couple of homework problems just to kind of get our brains moving in that way, and then we'll do some problem solving Tuesday and Wednesday. Thursday of this week, again, because this is a pretty simple, straightforward piece, mostly because you've done it before, we're going to quiz. So we're going to quiz on Thursday, and then you'll be working on a project, the egg drop project, and more information on that to come, but that'll happen Friday, Monday, and then next Tuesday, the 18th, we will take our test over Unit 4. Okay, so that will include all of the things that we've done. It will give you another opportunity to show me your knowledge and show me your understanding, and then we'll move on. We will do a little bit of material on that Wednesday, Thursday, Friday, because we can and we have the opportunity. But my hope is that any retesting or reassessment that needs to be done from Unit 4 can happen before winter break. Because I'm guessing that you don't want to have to come back after winter break and reassess over this stuff that you've hopefully not been worried about during the 2 weeks off. Does that seem reasonable? Okay, so here we go. We're going to jump in and talk about marketing today. How many of you have ever gone to the grocery store or wherever it is that you buy your toothpaste, okay, and you're looking for that green box or whatever, and you're looking and you're looking and you're looking and you are like, I know that my whatever toothpaste is here, but all of a sudden they've given you it's like a new box. Do you know what I'm talking about? Or it's a new bottle of shampoo that has like a new design, or maybe your Pepsi has a different logo or whatever. You know what I'm talking about? Yeah. And there's always that little like Starbucks, what's that?
Like the McDonald's bags.
The McDonald's bags, same, right? Now I don't know if they do it on the McDonald's bags because I think it's kind of like once you've gotten the bag, you've made the commitment, you've given them your money already. But in those other products where you're actually making the decision, like, ooh, do I still want to stay with this shampoo? Like, has it changed? Or do I want to, like, you know what I'm saying? There's always that little thing that says, like, new look, same formula, or something like that, right? Like, it's the same stuff, just presented differently. That's what I'm doing right now, okay? New look, same stuff. So here it comes, the lesson in marketing. So you have seen this product before, yeah? Net force causes an acceleration. True? We've been doing that for like months and months and months.
Credit card.
It's kind of like it, yeah. I got it from freelogodesigns.org because I wanted a logo, right? Yeah. But it's kind of like it, I guess. Yeah. So net force causes acceleration. This is not a surprise. You have known and we have studied and understood and solidified in our brains that acceleration is equal to F net over m. This thing is called what? What do we call that? It has a name, named after my least favorite, perhaps, scientist. What is A equals F net over m? Newton's first and second law? Yeah. I'm never going to ask you to like match. It would be like the weirdest physics test question ever. Match the equation to what it's called. Like, I wouldn't do that to you, right? Like, that's not physics, that's just memorization. But that's what this is. That's where it came from, was Newton's first and second law. So that's all well and good. We know it, we understand it, it's great, okay? So now, before your very eyes, I'm going to present you with the new and improved, perhaps, version. Same formula, new look. You with me? I love that you're shaking your head at me. It makes me happy. I love it, but hopefully it'll stick in your brain. Here it is. Impulse causes a change in momentum. Well, that sounds scary. There are words in there we don't even know. Some that we know, but we don't think they have anything to do with Newton's second law, right? So my job right now is to convince you that these really are one and the same. So here we go. Are there any words in this logo, in this thing that you've never heard before, or you've never heard, at least in the context of this class, before? Yes, no, yes. Stella, what is it? What are you saying? Going, I don't know what this is. Impulse, right? I don't know what that is. Well, I do, but you may be saying that. Impulse. Have you heard the word impulse in the context of other things before? Again, this is all about shopping for me. It's all about marketing. When have you ever heard the word impulse before? Ever?
Impulsive decision.
Impulsive decisions, absolutely. What does it mean to make an impulsive decision?
Just making decisions, not thinking pretty much. Like you see something in a store, you might not really need it, but you're like, oh, I want it, and then you just take it and you just buy it, and it's like you didn't really need it. You never use it again.
Yes. So there are people that sit in offices in Minneapolis, Minnesota, okay, who work for the Target Corporation, and literally it is their job to come up with impulsive purchases for you all and for me to deal with, okay? If you've ever checked out of any store, whether it's Fairway or Hy-Vee or Target or Walmart or wherever, you know that in that little aisle as you walk up to the cash register, they have all that candy, and they have all that chapstick, and they have all that other little stuff. You know what I'm saying? The things that were not on your list of things to purchase, but you're like, oh, I totally need that. And you buy it, right? Without really thinking, you do it. That's what an impulsive decision is. That's what an impulse buy is. Yes, absolutely. Impulsive purchasing, it's dangerous. It's dangerous, right? Impulse means that you were doing one thing, right? I've got all the things on my list, and now I'm just going to go check out at the register and go. But instead of going this way and I'm just happy and I'm doing my thing, oh, I see that Snickers bar. Oh, I see. What else do you think of? Batteries, I feel like I always see on the aisle. What else is in the aisle? What's that?
Gift cards.
Gift cards for sure, right? Absolutely. Yeah. All those little things that, again, you don't need, but you take it, or not take, but you purchase because it's right there. It's so convenient. So if you think about literally what you're doing, you're going to think about this next time you go to the store. Literally, you're moving this way. Let's map it, right? You're going this way, and then you turn to go this way, right? It's as if something applied a force to you, right? It accelerated you. It changed your velocity. Are you with me there? Literally, that's what it's doing. It's changing your velocity. It's causing a force. An impulse is defined as a force acting over a time. Okay? Force acting over a time. So if I was going to write an algebraic statement for it, impulse, I don't even think that they define it in your book, the letter that goes with it. I'm just going to look. I don't think they do. Sometimes they define it with the letter J, but I'm not going to worry about it. I'm just going to write it as F over a certain amount of time. It's a force that acts over a time. The game is that an impulse can be a big force over a little time, and you can have an equivalent impulse that's a little force acting over a big time, okay? They both have the same result, but it's some force that's acting over a time. Okay? That is what impulse is. Now, there's another little piece in here, right? So impulse causes a change in momentum. How do you write change in algebraically? What letter do you use for change in? You could, yeah, you absolutely can use subtraction. Like you got this thing minus this thing. Yeah. Is there a letter up there? Delta, that we can use for change in as well? Yeah. So you can also use this. So change in momentum, okay, literally just means momentum final minus momentum initial. Okay. Now, my claim to you is that this is exactly the same as Newton's first and second law. You're saying, that sounds a little fishy, Miss Carberly. I'm saying, just trust me. Just give me a shot. Let me play with you for just a second. So here we go. F delta T is equal to, I'll write this as momentum final minus momentum initial. That does not look like Newton's first and second law to me yet. But are we okay here at this pink statement that I've written before I move on? Okay. So I'm going to leave the left-hand side alone for a minute. I'm just going to call that F delta T. I know that momentum is what times what always?
Mass times
Velocity. Yeah. And you know what? Actually, I wrote this out a different way in my other one. And I like it better. I'm going to erase this. So if you're using a pencil, yeah, you get to use the back of your pencil. If not, I want you to just write this as change in momentum, which is really mass times, I'm going to write it this way, change in velocity, because I think that that will be better. Just for simplicity's sake. Still doesn't look exactly like Newton's first and second law. But wait, there's more. Change in means final minus initial. So this is mass times V final minus V initial. F delta T. That right-hand side, or left-hand side, excuse me, nothing has happened yet. So let's monkey with the left-hand side, shall we? I'm going to divide by delta T. Delta T on the left-hand side is going to go away. And on the right-hand side, if you look critically and think about this for a moment, have you ever seen that before? Change in velocity over time? On your equation sheet. What is change in velocity over time equal? Do you remember? Or what is that a definition for? What does it mean if something's changing velocity? What is it doing?
acceleration.
It's accelerating. Yeah. Just for kicks, I'm going to get rid of my m on this side. If I divide by m on the right-hand side, what do I have to do on the left-hand side?
Same thing.
Same. So let's do it. I'm going to divide by m over here. Then I'm just going to rewrite it because, lots of crossing out gets really confusing. But hey, look at this. F over m is equal to v final minus v initial over t. I'm going to put that in a yellow box again. You just told me that this was acceleration. F over m equals a. Have you seen that before? Net force divided by mass is equal to acceleration. Have you seen that before? Yeah, that's just this thing, right? Oh, look at that. Look at that. Are you with me? Is this making sense to you? So indeed, these two things, I'm going to write them out so we've got them side by side. A equals F net over M. And F delta T, it's really the net force, but I'm just going to leave it as F delta T, is equal to change in momentum. These are the same statement. Okay. The top one we usually call Newton's first and second law. The bottom one we usually call the impulse momentum theorem. But fun fact for you, if you go back and you read Isaac Newton's Principia, which was the thing where he defined all of this stuff, when he wrote down what we now know as Newton's first and second law, it did not look like this top box. He wrote down this. This is officially, like if you go back to his book, right? Look at what he wrote. He wrote the impulse momentum theorem. Okay. Again, was he the first person to have come up with it? No. He just happened to write it down and everybody's like, oh, Isaac Newton, oh! And they gave him credit for it. Whatever. I like to call it the impulse momentum theorem because that's better, right? Let's not give credit where credit isn't due, friends. Okay. How are we doing? Okay. Okay. So we're not going to get scared. On your homework, it's going to ask you on one of the questions to like calculate a momentum or something. You can do that. And then there's going to be one that says something like, hey, Find the force if you know the time and the change in momentum. Can you do that? It's not hard, right? Now, they might give you masses and velocity, so it might give you something more like this. But you can handle that, right? Yeah, you got that. You got that. We got 4 minutes, I think, right? Sweet. All right, we're going to do one ranking task to get our brains ranking, because who doesn't love a little ranking task in the morning? I guess it's afternoon now. All right. Identical boxes filled with different amounts of sand. Oh, that's kind of not exciting. I'm going to put chocolate chips in mine instead. Are initially at rest. A horizontal force is applied and the boxes move across the floor. The mass of the box and its contents and the net force acting on the box while horizontal force is applied are given. The question asks you to rank the magnitude of the impulse. We're not scared by that word anymore, right? Force times time, right? On each box for a 2-second time interval. Go ahead and do that. It's okay to talk to each other. Feel free to have a conversation. Rank the magnitude of the impulse. You guys feel like you have an answer or not quite yet? A little bit more time? Okay. I'll give you a little more time.
You can do that.
Ready? No? All right. Can somebody give me an answer? Doesn't have to be the right answer. Something to start from? Go, Josie. Yeah.
B is greater than A, that is greater than C, that is equal to D.
Okay, hold on. B greater than A, greater than C, equal to D. Ryan, how do you feel about that answer? Did you guys agree with that, or do you have something different?
I think we switched A and C.
So you said B is greater than C is greater than A is equal to D? I'm just asking them.
No, A is supposed to be at the end.
Oh,
C is equal to D, that's what I was just saying.
like that?
Yeah.
What did you say?
You could have D is greater than
D is greater than A is greater than?
no,
Oh.
equal to B. Wait. D is greater than A, which is greater than B. My bad. What you had first?
So tell me what you write again.
D greater than A, greater than B.
D greater than A, greater than B, greater than C? All right. I think the bell's going to ring. Maya, did you agree with any of those?
Agree.
Or do you have a different one?
I think it's a second one. I agree with that.
Ben, what about you?
I had a different one.
What did you have?
B is greater than C is equal to D is greater,
Holy cow, start over. B is what?
greater than C
Okay,
equal to D
okay,
greater than
okay.
Oh, that's
All right.
That's second one.
I think it's time for you guys to go. We'll talk about it tomorrow. Have a fantastic day, my friends.